Okay, this video is going to go over the wheel and axle problems that you were asked to work on in class and for homework. So the first problem asks, what is the linear distance traveled in one revolution of a 36-inch diameter wheel? So if we have a wheel, the distance traveled around the outside of a wheel is going to be the circumference of a circle, which is essentially equal to 2 pi r. Or it could be circumference equals 2 pi diameter. And you should have learned that in your geometry class. So if it gives us that the wheel is a 36-inch diameter, then all we have to do is plug in. So our formula here would be pi d. And if we substitute the diameter, it would be 36. So our final answer would be 36 pi. Okay. The second problem says an industrial water shutoff valve is designed to operate with 30-pound effort force. The valve will encounter 200 pounds of resistance force applied to a 1.5-inch diameter axle. So in this case, is the axle driving the wheel or is the wheel driving the axle? Well, it says that the effort force is being applied to the valve, right? And the valve is going to be the larger diameter wheel. So let's sketch this out. It'll make more sense when I sketch it out. So here's the valve that you're actually turning, right? And when you apply an effort force to turn it, the effort force is going to be on the outside. But we're dealing with the wheel and axle system, right? It tells you wheel and axle system. So we need to also draw our axle. Now, if our effort force is on the outside, then our resistance force has to be on the inside, right? And it tells us that our FE is going to be 30 pounds. It tells us that the FR is going to be 200 pounds. It also says the axle is going to be 1.5 inches in diameter, right? So from here to here, that's going to be our dr, okay? So our dr is going to be 1.5. Okay, so I've sketched it and I've identified what I know, and what I do not know is I do not know the outside diameter of the wheel, okay? So the next problem says, what is the required actual mechanical advantage of the system? So the AMA we know to be FR over FE, right? We know our FR. We know our FE, so if we just plug that in, 200 divided by 30, that gives us a final answer of 6.67 for our AMA. The last problem asks, what is the required wheel diameter to overcome the resistance force? So the wheel diameter is going to be our DE, and that's what we need to solve for. So we can use our equilibrium equation to do that. Right? And all we need to do is rearrange it in order to solve for the DE. This is just basic algebra, right? And if we plug what we know in, we know the FR, which is 200 pounds. We know the DR, which is 1.5 inches. Okay, and we know our FE, which is 30 pounds. If we do the math, then we should come up with a DE of 10 inches. Okay, that's your DE. Okay, that's it.